Welcome. Let's hope this science audio helps you fall asleep while your brain quietly absorbs a few facts about the universe. Let's start close to home. Earth orbits the Sun at about 30 kilometers per second, which means that while you're lying in bed, you're actually hurtling through space at over 100,000 kilometers per hour. And the entire solar system itself is moving too, drifting around the center of our galaxy at roughly 828,000 kilometers per hour. So even when you feel still, you're never actually still. The solar system formed about 4.6 billion years ago from a vast cloud of gas and dust left over from older stars that had exploded. Gravity pulled everything together. The center grew hot, and eventually the Sun ignited, a star born from collapse. Everything else, the planets, moons, comets, and asteroids, formed from the leftovers spinning around it. The Sun makes up 99.86% of all the mass in the solar system. It's so massive that its gravity holds everything in orbit, from tiny grains of dust to Jupiter itself. Without it, every planet would simply drift away into the darkness. Even the distances between planets are enormous. The Earth is about 150 million kilometers from the Sun, what we so call 1 astronomical unit. Light from the Sun takes about 8 minutes and 20 seconds to reach us. The next planet, Mars, is roughly 225 million kilometers away. And beyond that, Jupiter sits more than 5 times farther from the Sun than Earth. If the solar system were the size of a football field, Earth would be just a tiny speck of dust orbiting a marble-sized sun, while Neptune would be somewhere past the far goalpost. And yet, this isn't unusual. Our solar system is just one among billions in the Milky Way. Every single dot of light you see in the night sky, every star, could have planets orbiting it too. So far, astronomers have discovered over 5,000 exoplanets, and many are in regions where liquid water could exist. The key ingredient for life as we know it. Even the space between planets isn't empty. It's filled with solar wind, a stream of charged particles flowing outward from the Sun at hundreds of kilometers per second. It shapes magnetic fields, forms auroras, and defines the very edge of our solar system, a giant bubble called the heliosphere. Space might seem silent, but it's alive with motion, energy, and invisible forces. Every planet, every atom, every grain of dust is part of a system that's been turning in perfect rhythm for billions of years. So as you rest, remember, you're lying on a planet spinning at 1,670 kilometers per hour, orbiting the sun, which is racing around the Milky Way, which itself is gliding through the universe. You're part of something vast, and it's all still, somehow, perfectly balanced. Planets are the quiet artists of the universe. They don't shine like stars, but they reflect light beautifully. Each one a small, unique world with its own story. Some are giants, wrapped in colorful clouds. Jupiter, for example, is so large it could fit more than 1,000 Earths inside it. Its swirling storms and golden bands look calm from afar, but up close they stretch thousands of kilometers wide. And Saturn, with its bright rings of ice and dust, glides silently through space, a masterpiece of balance and beauty. Then there are smaller, rocky planets like Mars, Venus, and Earth. Mars, with its rust-colored deserts, once had rivers and lakes. Venus, glowing softly in the sky, hides beneath thick clouds that shimmer in the sunlight. And Earth, our home, is the rare one that learned to breathe. It has oceans, forests, and a sky that changes color every day. Moons add even more wonder. Jupiter's moon, Europa, is covered in ice, but beneath that ice may be an ocean deeper than all of Earth's combined. Enceladus, a tiny moon of Saturn, sprays plumes of water into space, a sign that life's ingredients may exist far from home. And Titan, with its thick orange atmosphere and rivers of liquid methane, feels like a world from a dream. All across the galaxy, planets like these orbit in silence, warmed by distant suns. Some are too hot, some too cold, and some, perhaps many, just right. The search for other Earth-like worlds continues, and with every discovery, we realize how vast and generous the universe really is. Every star you see at night could have its own solar system. Some may hold planets full of mountains, clouds, and sunsets. Somewhere out there, another sky might glow with a different color. Another ocean might reflect another sun. And maybe one day someone will look up there and wonder about us. Humanity has always looked up. Long before telescopes, people watched the stars move across the sky and wondered what they were. We told stories about them, drew shapes between them, and used them to find our way across oceans and deserts. And eventually, we began to reach for them. In 1961, a human left Earth for the first time, Yuri Gagarin, orbiting our planet in silence, seeing the world as no one ever had before. He described Earth as small, blue, and fragile, a single, shining home, floating in darkness. Since then, we've sent spacecraft to every planet in our solar system. We've seen volcanoes on Venus, storms on Jupiter, and icy plains on Pluto. We've walked on the moon and placed rovers on Mars that still send back pictures of alien sunsets. Every mission reminds us that the universe isn't distant. It's something we're part of. The same physical laws that shape galaxies also shape us. The same elements that form stars form our bodies. We belong here just as much as the planets and moons do. Space exploration isn't just about technology or discovery. It's about perspective. When astronauts look back at Earth from orbit, they see no borders, no divisions, just one glowing sphere of life, turning slowly in the light of the sun. As we continue to explore, we're not leaving Earth behind. We're carrying it with us. Every signal, every photo, every astronaut heartbeat is a reminder that we're extending the reach of home. One day, humans may live on other worlds. We'll plant seeds in Martian soil, breathe air recycled from alien ice, and watch new sunrises from new horizons. And when that happens, the story of life on Earth will have expanded, not ended, but continued across the stars. When you look up at the night sky, you're not just seeing stars. You're seeing light that's been traveling for thousands, sometimes millions of years. Light that began its journey long before you were born and is only just reaching your eyes now. Every point of light is a story in motion. Some are young, bright stars still surrounded by clouds of dust. Cosmic nurseries where new solar systems are forming. Others are ancient red giants, nearing the end of their lives, glowing softly in farewell. Together, they create a quiet tapestry of time. The colors we see, the faint golds, the icy blues, tell us about temperature, age, and distance. And though the sky may look still, everything up there is moving. Stars orbit the center of the Milky Way. Galaxies drift and turn. Even the constellations slowly shift shape over thousands of years. The sky above us tonight is not the same one our ancestors saw. It's slightly changed, and one day, far in the future, it will change again. But that's what makes it beautiful. It's alive. There's a certain peace in knowing that even in silence, the universe is busy creating, changing, and glowing endlessly. You don't have to do anything but look up. The stars are still there, still burning, still shining for anyone who needs a moment of calm. And the best part? You're made of them. Every atom in your body, the carbon in your cells, the iron in your blood, was once inside a star that lived, burned, and exploded long before the earth existed. So when you see the stars, you're not looking at something distant. You're looking at your own origin story, written across the sky. Let's start close to home. Our solar system has 8 planets, each orbiting the sun at different speeds and distances. Mercury is the closest, a small rocky world where temperatures swing from 430 degrees Celsius in the day to minus 180 degrees Celsius at night, because it has almost no atmosphere to trap heat. Venus, the second planet, is hotter still, around 465 degrees Celsius everywhere, thanks to a thick atmosphere made mostly of carbon dioxide. The air pressure there is about 90 times greater than on Earth. Then there's Earth, our home, the only known planet where liquid water exists on the surface and where the atmosphere is just right for life. Mars, the red planet, has mountains taller than any on Earth. Its volcano Olympus Mons is about 22 kilometers high, nearly 3 times taller than Mount Everest. Past Mars lies the asteroid belt, a wide region filled with rocky debris that never formed into a planet. Beyond that are the gas giants. Jupiter is the largest planet, so big that more than 1,300 Earths could fit inside it Its great red spot is a massive storm that's been raging for at least 350 years. Saturn is famous for its rings, made mostly of ice and rock. Some of the particles are as small as grains of sand, while others are as large as houses. Then come the ice giants, Uranus and Neptune. Uranus spins on its side, tilted 98 degrees, possibly from an ancient collision. Neptune, farthest from the sun, has winds over 2,000 kilometers per hour, the fastest in the solar system. Even farther out are dwarf planets like Pluto, orbiting in the icy region known as the Kuiper Belt. Everything in our solar system, from the smallest asteroid to the largest planet, formed from the same cloud of gas and dust 4.6 billion years ago. The sun is an ordinary star, but it's also extraordinary. It's about 4.6 billion years old and sits in perfect balance. Gravity pulling in and nuclear fusion pushing out. Every second it converts about 600 million tons of hydrogen into helium, releasing enough energy to power the entire Earth for billions of years. Light from the sun takes just 8 minutes and 20 seconds to reach us. That means when you look at the sun's light shining on your skin, you're seeing it as it was over 8 minutes ago. It's so massive that 1.3 million Earths could fit inside it, yet it's just the right size to provide the energy that allows life to exist here. Too big, and its lifespan would be short and unstable. Too small, and we'd be a frozen world. The sun is our quiet powerhouse, perfectly tuned for life, glowing at just the right distance and continuing its steady rhythm that's lasted for billions of years. Jupiter is more than just the biggest planet. It's the solar system's bodyguard. Its gravity is so powerful that it protects Earth by pulling in comets and asteroids that might otherwise hit us. Without Jupiter, life on Earth might never have survived long enough to evolve. It's a giant of gas, mostly hydrogen and helium, and it spins incredibly fast. One full rotation every 10 hours. That's why its clouds form stunning bands and swirls, including the Great Red Spot, a storm so large it could swallow Earth whole, and it's been raging for at least 350 years. Jupiter has 95 moons, each unique. Some, like Europa, are especially exciting because beneath its icy crust lies a deep ocean that could potentially harbor life. Despite being hundreds of millions of kilometers away, Jupiter's immense presence shapes our solar system. It keeps the inner planets stable, sweeps away danger, and shows us the raw, majestic power of nature on a scale beyond imagination. Saturn is the showpiece of the solar system, a planet so beautiful it almost looks unreal. Its rings, made of countless bits of ice and rock, stretch out more than 280,000 kilometers, yet they're only about 10 meters thick. From a distance, they look solid, but they're actually billions of tiny particles reflecting sunlight like glitter. Saturn itself is enormous, 9 times wider than Earth, but it's so light that if you could drop it in a giant cosmic ocean, it would float. Its atmosphere is a soft blend of yellow and gold, and it spins so quickly that a day lasts only 10.5 hours. And then there are its moons, over 140 of them, each one a small world. The most famous is Titan, which has lakes and rivers made of methane, thick clouds, and a dense atmosphere that feels strangely Earth-like. Scientists believe Titan could be a glimpse of what our own planet looked like before life began. Saturn reminds us that space isn't just vast, it's elegant. Even in the cold emptiness, beauty exists on an unimaginable scale. Uranus is one of the most unusual planets in our solar system. It doesn't spin upright like Earth or Jupiter. It rolls around the sun on its side. Its axis is tilted by 98 degrees, meaning it's practically lying down as it orbits. Scientists think this tilt might be the result of a colossal collision with another planet-sized object billions of years ago. Because of that extreme tilt, Uranus has some of the strangest seasons imaginable. Each pole gets 42 years of continuous sunlight, followed by 42 years of darkness. Imagine living in a world where the sun doesn't rise for 4 decades. It's an ice giant, filled mostly with water, ammonia, and methane ices beneath a layer of hydrogen and helium gas. The methane is what gives Uranus its soft blue color because it absorbs red light and reflects blue. But unlike Neptune's deep, vivid blue, Uranus is pale, almost like frosted glass. The planet is enormous, about 4 times wider than Earth, but its atmosphere is freezing, around minus 224 degrees Celsius, making it one of the coldest places in the solar system. Despite being so cold, Uranus still has faint rings, 13 of them, dark and dusty, discovered only in 1977, when astronomers saw them briefly block a star's light. Uranus also has 27 moons, most named after characters from Shakespeare's plays, like Titania, Oberon, Ariel, and Miranda. Each of these moons is unique. Miranda has cliffs taller than Mount Everest and surface features that look like the planet was shattered and reassembled. Titania is covered with canyons stretching for hundreds of kilometers. Ariel shows signs that icy material once flowed across its surface, maybe from ancient cryovolcanoes that spewed out water and ammonia instead of lava. One of the strangest things about Uranus is how quiet it is. Unlike Jupiter or Saturn, it has no massive storms that we can see. It's calm, still, and eerily steady, a frozen blue marble spinning sideways through space. Yet despite its quietness, Uranus holds huge mysteries. Scientists still don't fully understand its internal structure or why it's colder than Neptune, even though it's closer to the sun. There's even evidence that it might rain diamonds inside, deep within the pressure-filled layers. Methane could break apart and form carbon crystals that fall like glittering diamond rain. In its tilted solitude, Uranus reminds us that space isn't perfect symmetry. It's filled with accidents, collisions, tilts, and surprises, yet somehow it all keeps moving in harmony. Neptune is the farthest planet from the sun, a deep blue world over 4.5 billion kilometers away. Sunlight takes more than 4 hours just to reach it. Even at that distance, Neptune is anything but quiet. It's a world of extreme weather and power, where winds roar at 2,100 kilometers per hour, the fastest ever recorded in the solar system. This distant planet was actually discovered through mathematics before it was seen through a telescope. Astronomers noticed Uranus wobbling slightly in its orbit, as if tugged by an unseen force. They calculated where that force must come from, and when they looked, Neptune was exactly where the math predicted. That was in 1846. and it remains one of astronomy's greatest triumphs. Neptune's color is mesmerizing, a deep, vivid blue caused by methane in its atmosphere, which absorbs red light. But that color might also come from something else. Scientists suspect an unknown gas or atmospheric process gives Neptune its uniquely rich shade, darker than Uranus's. Its atmosphere is a chaotic mix of hydrogen, helium, and methane, with huge storms spinning across the surface. The most famous was the Great Dark Spot, discovered by Voyager 2 in 1989, a storm the size of Earth that vanished a few years later, only for new ones to appear. These massive tempests form and disappear faster than anywhere else in the solar system, showing just how dynamic Neptune really is. Beneath the swirling clouds lies an icy, slushy interior of water, ammonia, and methane ices, and possibly a rocky core. It's so cold that temperatures drop to minus 220 degrees Celsius. Yet Neptune still radiates more than twice the heat it receives from the sun. That means it's generating its own internal energy, possibly from slow gravitational compression or leftover heat from its formation. Neptune also has a faint system of 6 known rings, dark and dusty like those of Uranus, and 14 moons. The largest, Triton, is a world of its own. It orbits Neptune backwards, in the opposite direction of the planet's rotation, meaning it was probably captured from the Kuiper Belt long ago. Triton has active geysers that shoot nitrogen gas into space and an icy crust that may conceal an ocean beneath. Over time, Neptune's gravity is slowly pulling Triton closer. In hundreds of millions of years, it will be torn apart, forming a spectacular ring system, turning Neptune into a world of rings like Saturn. Even at the edge of the solar system, Neptune hums with energy. It's proof that even in the coldest, darkest places, there's still movement, still warmth, still life in the laws of physics themselves. Beyond Neptune lies a vast, silent region known as the Kuiper Belt, a frozen ring of worlds, comets, and icy debris stretching from about 30 to 55 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, about 150 million kilometers, so we're talking billions upon billions of kilometers away. The Kuiper Belt is like a time capsule from the dawn of the solar system. It's full of the leftovers from when the planets were forming, chunks of rock and ice that never quite merged into a planet. Out here, sunlight is so faint that it's more like a soft twilight, and temperatures drop to nearly minus 230 degrees Celsius. The most famous resident is, of course, Pluto. Once considered the ninth planet, Pluto is now known as a dwarf planet, but that doesn't make it any less fascinating. It's only about 2/3 the size of our moon, yet it has mountains made of water ice, plains of frozen nitrogen, and even a thin blue atmosphere. Its heart-shaped glacier, called Tombaugh Regio, reflects sunlight so brightly that it's visible even from billions of kilometers away. Pluto's largest moon, Charon, is almost half its size, so large that the two actually orbit a common point in space, like a cosmic dance. Their mutual orbit creates a strange balance, as if they're forever locked in each other's gravity. But Pluto isn't alone out there. Other dwarf planets share this frozen region. Eris, slightly smaller but more massive than Pluto, was the discovery that forced astronomers to redefine what a planet really is. Haumea, shaped like an American football, spins so fast that its day lasts only 4 hours. Make, covered in frozen methane, gleams faintly under the distant sun. The Kuiper Belt is also home to countless smaller bodies, trillions of them, that occasionally get nudged by gravity and sent tumbling toward the inner solar system. When that happens, they become comets, bright tails of gas and dust that flare as they approach the sun, giving us spectacular shows in the night sky. Every comet that streaks past Earth is a messenger from this icy frontier. Beyond the Kuiper Belt lies a place so distant that the sun becomes just another star in the background. This is interstellar space, the space between the stars, and it begins at the edge of the heliosphere, the invisible bubble created by the sun's constant outflow of charged particles, called the solar wind. The boundary where the solar wind finally runs out of strength is called the heliopause. It's about 18 billion kilometers from Earth, so far that light takes 17 hours to reach it. Inside this bubble, we live under the protection of the sun's magnetic field. Outside it, the space between stars is filled with cosmic rays, high-energy particles that travel across the galaxy. Only 2 spacecraft in history have ever crossed this line, Voyager 1 and Voyager 2. Launched in 1977, they've been traveling for nearly 5 decades, and both are now more than 20 billion kilometers from home. Each carries a golden record, a time capsule containing sounds and images from Earth, greetings in 55 languages, whale songs, Bach, Chuck Berry, and the sound of rain, a message in a bottle for anyone or anything that might one day find it. Out here, there's no up or down. The sun's light is just another point among thousands. The temperature drops to just a few degrees above absolute zero, and the particles of matter are so spread out that a single cubic meter might contain only a few atoms. Yet, this space isn't truly empty. It's filled with a thin fog of hydrogen gas, magnetic fields, and the faint traces of dust from dead stars. And even in this emptiness, the solar wind continues to push outward, carving our sun's mark into the galaxy. It's a constant reminder that even from so far away, our star still influences its surroundings. A bubble of life, light, and energy, stretching billions of kilometers into the dark. What's truly amazing is that Voyager 1, despite being launched when computers filled entire rooms, is still sending back faint radio signals. It transmits with less power than a refrigerator light bulb, yet we can still hear it from over 22 billion kilometers away. Each signal takes more than 20 hours to reach us. Eventually, in about 30,000 years, Voyager will pass near another star system. By then, Earth will have changed completely. But those little spacecraft will still be drifting silently between the stars, carrying our story across the galaxy. Out here, beyond the heliopause, time feels slower. The familiar warmth of the sun fades, but the wonder grows. Interstellar space is the threshold between what we know and the infinite beyond, where one star's influence ends and the next begins. The Milky Way is our home galaxy, a sprawling, rotating city of stars stretching 100,000 light years across. It contains over 400 billion stars, countless planets, and enormous clouds of gas and dust. From Earth, when you look up on a clear night and see a faint milky band of light crossing the sky, that's the disk of our galaxy, the combined glow of billions of distant suns. At its heart lies something both mysterious and powerful, a supermassive black hole called Sagittarius, a star. It's about 4 million times the mass of our sun, and though it's invisible, we can see the stars orbiting around it at incredible speeds, some completing a full orbit in just a few years. The Event Horizon Telescope even captured its shadow in 2022, a glowing ring of light around a dark void, proving Einstein's theories yet again. The Milky Way is shaped like a barred spiral, with long curved arms that sweep outward from the center. Our solar system sits out on one of these arms, called the Orion Arm, roughly 26,000 light-years from the galactic center. We orbit the center of the Milky Way once every 230 million years, meaning the last time we were in this part of the galaxy, dinosaurs were just beginning to roam the Earth. Our galaxy is full of variety. There are open clusters of young, hot blue stars just recently formed from clouds of gas. There are globular clusters, ancient and dense, containing some of the oldest stars in the universe, many over 12 billion years old. Between the stars are vast nebulae, colorful, swirling clouds where new stars are born. The Eagle Nebula, for example, contains the pillars of creation, enormous towers of gas and dust stretching 5 light-years tall, sculpted by the radiation of newborn stars. The Orion Nebula, visible to the naked eye as a small fuzzy patch in Orion's sword, is another stellar nursery, glowing with pink and violet light from hydrogen gas energized by the stars forming within it. And all around us, the galaxy hums with quiet motion. Stars orbit the center, drifting gently through space. Clouds collapse and ignite, creating new stars, while others die in magnificent supernova explosions that scatter heavy elements, carbon, oxygen, iron, the very ingredients of life. As we drift beyond the Milky Way, the scale of everything becomes almost impossible to grasp. The stars we see are just a few thousand out of hundreds of billions in our galaxy, and our galaxy is just one among over 2 trillion others scattered across the observable universe, each one filled with its own suns, planets, and stories. Between galaxies stretches intergalactic space, vast and mostly empty, though even here, faint trails of gas and dark matter connect the universe like invisible threads. The galaxies themselves gather into clusters and superclusters, and beyond those, into an enormous web-like structure spanning billions of light years. From far enough away, the universe looks like a glowing network of filaments, where galaxies trace the outlines of cosmic voids. It's all still expanding. The universe has been growing since the Big Bang, about 13.8 billion years ago. Space itself is stretching, carrying galaxies away from one another faster and faster, driven by something we call dark energy, a mysterious force that makes up about 68% of the universe, yet remains completely unexplained. Despite all this scale, despite the unimaginable distances, what's remarkable is how everything follows the same simple rules, the same physics that make apples fall on Earth also govern how stars form, how galaxies spin, and how black holes bend light. The universe isn't random chaos. It's intricate order on the grandest possible scale, and we're part of it. The atoms in your body were once part of ancient stars. You are, quite literally, made of the same material as the universe itself, stardust, assembled into something capable of looking back and wondering where it came from. When you look up at the night sky, you're not looking into the distance. You're looking into the past. The light from some stars has traveled tens of thousands of years to reach you. From distant galaxies, the light is millions or even billions of years old. Every pinpoint you see is a window into history, a glimpse of the universe as it once was. And though it's so enormous, so beyond our comprehension, it's not frightening. It's beautiful. It's calm. It's steady. The stars don't rush. The galaxies don't hurry. Everything unfolds at its own quiet pace, the same way it has for billions of years. As the light of distant suns fades and the vastness of space stretches out in every direction, there's a simple comfort in knowing we belong to all of it, part of the same story that began long before us and will continue long after. So if you're listening to this to fall asleep, let the thought settle in. You're resting beneath the same stars that have watched over everything since time began. You're made of the same particles that built the galaxies. You're part of the universe, and the universe is part of you. Good night.